Hello friends, today I am going to teach you how to draw a shear force and bending moment diagram for the given beam section. This is my problem. It is carrying a uniformly distributed load and the intensity of the uniformly distributed load is 6 kN per meter. The whole length of the section is 6 meter and this is the support reaction. I mark this RA and RB. First of all, I explain the whole process of this video. Okay, first of all I have to find out the RA and RB values. Then I find out the shear force and bending moment values for the measured length of the beam sections. Then using those shear force and bending moment values, I can draw the shear force and bending moment diagram. Apart from that, in this problem I am considering the sign convention. Okay, here's my sign convention. Upward forces clockwise movement positive, downward forces anti-clockwise movement negative. Then my next step is find out the RA and RB values. Due to this beam section is equilibrium, I can consider in the upward forces minus downward forces is equal to 0. Okay, RA and RB are upward forces, that's why this is positive. Here 6 kN per meter is the intensity of the UDL, so I can multiplying into length of the beam section. It is 6 meter, so the product is kilonewton. Okay, this load is acting downwards, that's why this is minus, and RA and RB values are upward forces, that's why this is positive. Okay, then I can get a movement from the RA point. I am considering this point to get the bending moment, so RB into 6 meter, it is anti-clockwise direction, this is minus, and here load acting on the downwards, so this is clockwise movement, that's why this is positive. Then solving this expression, I can get a value for the RB, and using this expression I can get a value for the RA. Okay, our first step is done. Then I am going to move my second step. My second step is I am going to find out the shear force and bending moment values for the selected length of the beam section. Firstly, I am find out the shear force for the selected length of the beam section. Okay, firstly I am considering 0 to 6 meter range. So for more easier for the calculation, I can draw the beam section relevant to 0 to 6 meter range like this. Okay, this is the beam section relevant to 0 to 6 meter range. I want to say something. There is a special thing I am going to do. That is, I am marking the shear force as downwards like this. Okay. This is the very special things we want to consider. Okay, then I want to say another thing. This is I am selecting this 6 meter because there is no any another loads acting on the beam section from 0 to 6 meter. Okay, that's why this is I am selecting 6 meter. So now the calculation is very easy, so we can consider upward forces minus downward forces is equal to 0. Then I can get a value for the shear force. Okay, this is the expression. Shear force I mark downwards, so that's why this is minus. 18 kilonewton is the upward force, therefore this is positive. Then there is another load acting on the middle point of the beam section due to UDL. This is downwards, it is acting on the downwards, so therefore this is minus. Here 6 kilonewton per meter into x meter. The selected beam section I have marked x meter, so we know that this is the UDL. We want to convert into load, so we know that this is kilonewton per meter. I can multiply into x meter, so this is convert into kilonewton. Okay. Okay, I have gained an expression for the shear force with x, so I can substituting x as 0 and 6, I can get a value for the shear force. When x is equal to 0, the shear force value is 18 kilonewton. When x is equal to 6 meter, the shear force value is minus 18 kilonewton. Okay, we have finished our calculation for the shear force. Then I am going to calculate the bending moment for this range. Okay, this is the beam section relevant to this range. Now I am going to mark the bending moment for this section. So my bending moment point is this point. So I will mark the bending moment like this. Then according to the sign convention, I can write the clockwise movement minus anti-clockwise movement is equal to 0. I have marked bending moment anti-clockwise. So this is minus. This 18 kilonewton into x means clockwise movement. Therefore this is positive. Due to UDL, there is a load acting on the midpoint of the beam section. So this is downwards. Therefore this is anti-clockwise direction. Therefore this is minus. Then apart from that, I want to explain this expression. This 6 kilonewton per meter into x means load. This is the whole length of the beam section is x meter. Intensity of the UDL is 6 kilonewton per meter. So the load is 6 into x. Okay. Then I want to get units of the bending moment. So I have to multiplying another length with this expression. Okay. So this x divided by 2 means the whole length is x meter due to UDL load acting on the middle point of the beam section. So I want to measure the length between middle point of the beam section and the bending moment point. So this is x divided by 2. That's why I am multiplying x divided by 2 meter. We have gained an expression with x, so I can substituting x as 0 and 6. I can get a value for the bending moment. Okay, when x is equal to 0 and 6, the bending moment value is 0. Okay, we have already find out our shear force and bending moment values for the each beam sections. Then our next step is draw the shear force and bending moment diagram. Before draw the shear force and bending moment diagram, I am drawing the free body diagram of the given beam section. Then I will draw the axis of the graph. Then I will name the axis and the units. The units of the shear force is kilonewton and the units of the bending moment is kilonewton meter. This axis is indicate the length of the beam section. Okay. This x value measured along the beam section. Firstly, I am going to draw the shear force diagram. When we considering 0 to 6 meter range, we have two shear force values. When x is equal to 0, shear force is 18 kilonewton. When x is equal to 6 meter, shear force is minus 18 kilonewton. I can put the coordinates on the graph. 0, 18, 6, minus 18. When x is equal to 0, the shear force is 18 kilonewton. And when x is equal to 6, the shear force is minus 18 kilonewton. X is equal to 6. Here. Okay, we have already put the coordinates on the graph. So now we want to continue these 2 points with lines. Okay, but we don't have any clear idea about this is angle line or curve. Okay, so we can see the expression relevant to 0 to 6 meter range. It is shear force is equal to 18 minus 6x. This is like y is equal to mx plus c. Okay, we know the shape of this graph. This is angle line with negative gradient. I can continue these 2 points with angle line. The area of the both triangles are same. Here 18 kilonewton, here 6 meter. You know this is UDL. So this line cross the x-axis at the 3 meter point. Okay. Okay. Now I am going to draw the bending moment diagram. We have gained the two bending moment values here. When x is equal to 0 and when x is equal to 6 meter, the bending moment value is 0. Okay, I can put the coordinates here. When x is equal to 0, the bending moment is 0 here. Then when x is equal to 6, the bending moment is 0 here. Okay, we have put the coordinates on the graph. Again we have come the problem how we continue these 2 points. Okay, this is angle line or curve. Okay, again we can see the expression. This is like ax square plus bx plus c. So we know the shape of this minus ax square plus bx plus c. It is a curve. due to this minus mark it is upward curve. Okay, I can draw like this. Okay, we have drawn the shear force and bending moment diagram. Here this is 0, this is 6 meter, and we know that when the shear force is 0, the bending moment has maximum value. We can substituting x as 3. I can get a value for the maximum bending moment. It is 27 kilonewton meter. Okay, this is the shear force and bending moment diagram for the given beam section. I hope this is very useful for your some kind of problem related to this. So thank you.